This video shows how to calculate the effect size coins D in the case of no observable interaction, but observable main effects for the mixed ANOVA and SPSS. First of all, this is about pairwise comparisons, i.e. whether group differences or differences over time exist. An effect size should also be calculated for the calculated pairwise comparisons that have a sufficiently small p-value. As these are pairwise comparisons, coins D is used, the calculation of which I will now show. Note, I have already shown the calculation of eta squared, whether partial or generalized, which quantifies the strength of the interaction effect or the main effects themselves. Before we start, a quick note. If an interaction effect can be observed, the main effects are usually ignored. With an interaction effect, we found out that the within subjects and between subjects effects are interdependent and should therefore not be interpreted separately. In my example, an interaction effect is observable, which is why I would not be interested in the main effects. For teaching purposes alone, I'm showing it for this example. Let's start with the simpler pairwise comparison that originates from the within subjects effect. We need to check for which pairwise comparison over time the p-values are sufficiently small. In my example, this is only the case for the comparison between T1 and T5. As these are repeated measurements, a paired t-test is calculated. Incidentally, group membership does not need to be taken into account at this point, as the within subjects effect always ignores this. Go through Analyze, Compare Means and Proportions, Paired Samples t-test. Now enter the pairwise comparisons that could be observed in the corresponding fields. In my example, only T1 and T5. The selection of the standardizer is a tricky decision because the correlation of the measured values at the time points leads to a more or less large correction. Here, I recommend following Grissom-Kim, page 87 to 88, and sequentially requesting both the standard deviation of the difference and the corrected standard deviation of the difference. As other studies often only report coins D, but not which standardizer was used, this sometimes results in inconsistent effect sizes. For the output, only the bottom table, paired samples effect sizes, is of interest, shown here directly below each other. The effect sizes are reported as absolute, aka positive values. One can see that there's a difference of approximately 0.2 in the effect sizes. If no similar studies or research field specific thresholds exist, the thresholds from Cohen 92, page 157 can be used. However, it should be noted here that the thresholds refer to the calculation not adjusted for the correlation of the measured values. Let's now calculate the effect sizes for the pairwise comparisons which originate from the between subjects effect. I only have two groups and was able to observe a difference. However, the within subjects factor is not taken into account here. Instead, the mean value over time is calculated from all measurements for the individuals, and those means are then compared between groups. Let's quickly do the calculation first. Go through Transform, Compute Variable. I use the mean function to calculate the mean value over all 5 measurements. Mean underscore t is the name of my variable, and I put all the measurement variables into the mean function. After the calculation, I have the mean value of the score per individual over time. Now I compare this value according to group membership, i.e. experimental and control group, using an independent t-test. Go through Analyze, Compare Means and Proportions, Independent Samples t-test. The newly calculated test variable, mean underscore t, is entered into the test variable field, and the groups must be defined according to their value label coding. The Estimate Effect Sizes box should be ticked automatically, and the results can be requested. As a result of the calculations, coins D can be reported. Alternatively, Hedges correction of D, if you follow the recommendation of Grissom-Kim, page 69. Again, it is recommended to report the effect size in absolute, aka positive values. In my example, 1.195. This is then compared with similar studies and classified. Alternatively, research field specific thresholds can also be used. If neither is available, Cohen 92, page 157 can be used. After you've done all calculations, the results are reported, which is shown in the following video.